Hello guys, myself Azhar Pasha. I'm studying in Computer Science and Engineering in MS Ramaya. I'm going to show you a brief demonstration on the configuration of IoT devices and servers using the latest version of Cisco Packet Tracer, that is 7.0. This latest version supports both the networking devices and the IoT devices. Cisco Packet Tracer is a network simulation tool that can be utilized for the training of CCNA, CCNP certification exams by allowing students to create almost unlimited number of networking devices and to experience troubleshooting without having to buy a real-time routers or switches, through which you can able to design the network virtually and implement it practically. Before that, I'm going to show you how to download and install the latest version of the Cisco Packet Tracer in my next video. Keep on watching. So to download the latest version of the Cisco Packet Tracer, I given the links in the description below. It supports 64-bit, 32-bit and Linux operating system. My system is of 64-bit version. So copy the link in the description. Open your browser and paste it. I place this file in a Google Drive so it make easy for you guys to download. Just click on the download button. It is a 78 MB file. It does not contain any virus. I officially downloaded it from the netacat.com. So download it. I'm going to cancel this download because I have already downloaded in my downloads folder. Open your downloads folder. Okay, the download is complete. It is a 64-bit setup. Just for the installation, double click on it. Allow the user control, press yes. This is the welcome screen for the setup. Click next. Accept license and agreement for the software. Click on next. This is the path where it is going to install. Click next. This is going to create a folder in start menu. Just click next. For the additional task, it will create a shortcut menu for on desktop. Click next. This is a detailed description of installation. Click install to install the software. It will take time to install. I am going to pause the video for a minute. Okay, the installation is gonna finish now. If you have any browser open, just close the browser and click on OK. To launch the Cisco Packet Tracer, click on Finish and close the folder. An integrated login will pop up. Use guest login. If browser is open, just close it. Wait for the countdown. Confirm the guest login. Click on Confirm Guest. Okay, this is the latest version of the Cisco Packet Tracer, that is 7.0. In the networking devices, as you can see, in cloud, generic cloud, cable modem, DSL modem, and in the end devices, you can see the IoT devices such as smart city, such as fan, LED bulbs, smart LED, and street lamp, webcam, and the wind turbine. So in my next video, I'm going to show you a brief interface overview of the Cisco Packet Tracer. Till then, keep on watching my videos. Thank you. Hello guys, welcome back to my video log. As we know, Cisco Packet Tracer is a fancy e-learning tool made by the Cisco that will stimulate the working of network based on the topology and the configuration imposed by the users. It's exactly like the original network. When you open the Cisco Packet Tracer, you will be presented with the following interface. In my next video, I'm going to show you the brief interface overview and the new features of Cisco Packet Tracer. Till then, keep on watching, enjoy the video. When you open the Cisco Packet Tracer, you can see the following interface. The initial interface contains the 10 components, that is main menu bar, main toolbar, common toolbar, logical or physical workspace and navigation bar, workspace, real-time or simulation bar, and the network component box, device specific selection box, user created packet window. If you are unsure of what particular item does, just move your cursor over the item and the help balloon will explain the item, such as print, activity wizard, copy, paste, undo, redo, physical workspace, delete, draw a polygon, add simple PDU, add complex PDU, and so on. In the main toolbar, this main toolbar provides a shortcut menus for the file and edit options such as new, open, save, print, activity wizard, copy, paste, undo, redo, zoom, zoom in, zoom out, drawing palette, and the custom device. On the right hand side of the window, you can see the network information and the contents. In the network information button, which you can use to enter a description of the current network. To explain the common toolbar, let me take an example from the desktop. Open desktop, building a network. Okay. The selection tool provides, you can select any of the device and drag and drop, or you can select the whole network and you can drag to anywhere in the workspace. Using the place node, you can place a network information such as an IP address 192.168.2.1. This side of the network, it has 192.168.2.2 network. By using the selection tool, you can arrange the node anywhere in the workspace. Delete toolbar is used to delete an item from the workspace. There is only one undo is possible. Control Z. Using the inspect element, you can find the network information such as routing table, ERP-v6 routing table, ARP table, NAT table, quality of service queues, port status summary table. In the routing table, you can see the certain information such as network IP address, port, next hop IP, and the metric. In the switch, you can find the MAC table, ARP table, quality of service queue, port status summary table. In the MAC table, you can see the certain MAC addresses in which port. In PC, you can find the ARP table and the port status summary table. In port summary status table, whether the PC is, the link is up and the IP address is assigned or not, and the MAC address of the PC. By using the drawing a palette window, you can draw an ellipse, rectangular or line. Select any of these, fill the color or no fill the color, select any color you want, draw upon the network. Change the other color for the other network. Select any other color. The next tool is resize shapes. From this you can resize the drawing palettes. So let me delete this drawing palettes. Add simple PDU is a simple ICMP packet which you use for pinging from one PC to other PC. Select the source PC and the destination IP. You can see the status of the pinging. Let's try once again. Select the source IP and the destination IP. The first packet is failed because this switch and this router does not know the MAC address of this destination IP. So first it will send an ARP packet through the network, and this PC will reply an ARP packet with the MAC address. Then the transformation happens and the destination will reach the packet and it will ping back for the source IP. The second packet is successful because it knows the MAC address of destination IP. Let's try once again. From this side, this is source IP, this is destination IP. The packet is successful. Add complex PDU is a same ICMP packet but with little preferences. So let me take a complex PDU, select and source IP address. By choosing such application, depending upon your testing, you can choose any of the applications such as IMAP, HTTP, FTP, SFTP. I will use ping. Put the destination folder where you are going to ping. The destination IP is this 192.168.1.2 and the source IP from where the packet is traveling 192.168.2.2 and the sequence number for the packet, that is 3. Size of the packet 100 in 2 seconds. Click on create PDU. You can see the status of the packet, such as it is successful. The destination IP address, it is an ICMP packet in 2 seconds with sequence number 2. So let's see the next one. Logical workspace and the physical workspace. In logical workspace, you can create a new cluster, set a title, background, viewports. In the physical workspace, you can navigate through new city, new building, new container, new closelet, and the sector, background, wiring closelet. Navigate to the home city, place the corporate office in one place, create a new building using the new building tab, navigate into the corporate office. You can see the wiring closelet and the main wiring closelet. Inside that you can see the rack containing a router, switches, PCs. You can move the device from one place to another place, that is one city. I created new office building, move to the office building. The PCs are moved into the new office building. As you can see, the link is created. Click on the office building, create a new closelet for the PC, move this PC to the wiring closelet, this building wiring closelet. Now you can see inside the rack it has PC 0. Navigate back to the home city and the logical workspace. So workspace is an area where you create a network, watch simulations and view many kinds of information and statics. In real-time or simulation bar, you can toggle between each mode. In real-time mode, you can see the buttons such as power cycle devices, fast forward time, and in the simulation mode, you can see the play controls such as back, auto capture or play, capture or forward, and as well as the event list. This mode also contains a clock that displays relative time in real time and simulation mode. The network component box contains different set of devices such as networking devices, end devices, and the components. In the networking devices, you can see the routers, switches, hubs, firewall, security, WAN emulations. To select any of the device to the workspace, just select the device, in devices, select the type of the device you want to select, drag upon the workspace by using device type selection box. The user created packet window has different sets such as fire, lost status, source, destination, type, type of the packet. You can create a number of packet scenarios in real-time mode as well as in the simulation mode. So the next tool has real-time and the simulation modes. In the real-time mode, you can see the power cycle devices, fast forward the time, and in the simulation mode, you can see the power cycle device, play control buttons such as back, auto capture or play, capture or forward the packet from one device to another device. So let me take one simple example. Add a simple PDU from source to the destination. If you see this packet in a real time, the packet will be successful because it will travel very fast that we can't see. When you click on the packet, you can see the different OIC model layers. In the network layer, you can see it has a source IP address, destination IP address, and the type of the message. In the data link layer, it creates a MAC address and the next hop IP address in the ERP table. The device encapsulates the PDU in the Ethernet frame. In the physical layer, it sends out the frame. You can also see the outbound PDU details such as Ethernet 2 and the IP header and the ICMP headers. When you click on the capture and forward, the PC will pass the packet from one device to the other device, from switch to the router, from router to the switch, from switch to the destination PC. When you click on the auto capture, you can see automatically it will transfer from one device to other device. You can set the speed by using speed control bar. Once the packet is successful, click on the reset simulation to stop the simulation. In the user created packet window, you can see the last status, source, and the destination and the type of the packet. in what seconds the packet is going to travel. You can edit the packet. You can edit the packet if you want and create it as complex PDU, and if you don't want, and you can delete the packet. From the options menu, you can set the preferences for the network, such as you can always show the port labels in the logical workspace and play a sound and show the link lights by showing the link lights and play a telephonic sound when the telephone is added. In the administrative, you can set the password for the interfaces. In the hide tab, you can hide the physical tabs, hide desktop tabs, hide GUI tabs, hide attribute tabs, and so on. In the font, you can set the application size, and in the command line interface, you can change the font and size of the command line interface. In the workspace and activity wizard, you can change the font and size of the interface. If you don't want to apply the size of changing the font, you can just click on the reset for the default settings. Delete this network. Let me show you the new feature of Cisco Packet Tracer, that is Activity Wizard. Activity Wizard can be found from the extensions menu. Activity Wizard, Multi-User, IPC Scripting. These options can be used only when you are using the instructor version to create an assignment for the students. Like, just click on the Activity Wizard. This is a welcome screen for the Activity Wizard. In this, you need to create a different sets at different levels. First, you need to create an answer network, then an initial network. You need to put a constraint for the user abilities, then write a clear set of instructions for the activity, then password protected activity to prevent the unauthorized changes, then save the activity as PKZ. In this information, you provide the original author details. In the instructions tab, you need to create an HTML page for the instruction. When you click on the answer network, you can see the workspace where you need to create an answer network that is fully working answer of an assignment. In the initial network space, you need to create an initial network. You just need to place the devices without giving the connections. Then again click back the initial network wizard. For the password, when you create a password, it disables the unauthorized access. After creating a network, save the network as PKZ, give some name, click on save, and share the file with the students for the assignment. Let me show an example of the activity wizard. Open the file, desktop, instructor assignment. The assignment is follows like this. You can see the initial network on the left hand side and the instructions on the right hand side. By using these instructions, you need to create a fully final network. You can check the results from the check results. If the activity is incomplete, it will show the overall feedback. In the assignment item, you can see the different set of devices are available. If you complete the activity, you will get a tick mark. If it doesn't complete the activity, you will get a cross mark. In the connectivity test, you can find the different status, text conditions, points you got, source IP and destination IP, and the type of the assignment. The time will be keep on elapsing. The time will be keep on increasing. The time given for the assignment need to be completed within the time. So in my next video, I'm going to show you the configuration and the combination of both networking devices and the IoT devices. Till then, keep on watching, enjoy the video. Hello guys, welcome back to my video log. As we know, Internet of Things is one of the most upgrading technology in the present world. The IoT requires a network that can handle the increased demand for data analytics, security, and agility. Embedded system is playing a crucial role in the development of IoT. The four main components of IoT system: the device, local network, internet, and the backend services. IoT systems are not complicated, but designing and building them is a complex task. And even through a new hardware and software being developed for the IoT systems, we already have all the tools that we need today to start making the IoT into reality. A wireless sensor is a collection of distributed sensors that monitor the logical and physical conditions such as temperature, sound, and pressure. Data from each of these sensors passes through the network node to node. The wireless sensor network technology includes Wi-Fi, low-power solutions, IPv6, where IPv6 is a key for IoT. Hence, Cisco has finally announced a new version of Cisco Packet Tracers. They made some great changes in the user interface and support. New version of Cisco Packet Tracer is loaded with lot of new features like new networking devices, IoT, sensors, and programming language. Students taking the huge benefit from the newer version. I will show you a demo on smart home using IoT and networking devices with some servers and gateway. So let's get started. Enjoy the video. So for the configuration of smart home, first we'll design the network. Take 2911 router and rename it as ISP router, and take a switch, that is 2960 switch, and take two generic servers, one for the DNS, other for the IoT server. And take a cable modem and take a generic cloud for the WAN. Take a home gateway from the wireless devices. For the home gateway, the end devices are laptop, and the IoT devices, a webcam, window, and a siren, a lamp, door, and a fan. On the other side of the network, I will use cellular network. From the wireless devices, select central office server and a cell tower. The end devices for the cell tower is a smartphone. So this is my network design for the smart home. Connect using the connections. A coaxial cable from the cell tower coaxial to central office coaxial 0/0, and a crossover cable from central office server backbone to ISP router gigabyte 0/2. From the gigabyte straight through cable 0/1 to WAN Ethernet 6. Again from the ISP a gigabyte 0/0 to switch gigabyte 0/1. From the switch, take the fast Ethernet port 0/1 to the DNS server, and one more port fast Ethernet 0/2 to IoT server. Take a coaxial cable from the WAN cloud coaxial 7 to cable modem port 0. From the cable modem to home gateway, take a straight through cable port 1 to internet. So configure the home gateway to connect the all other devices. In real time scenario, this is how home gateway looks like. Ethernet port, LAN ports, and a Wi-Fi wireless antenna. Get into configuration tab, click on the wireless, change the SSID name to smart home, and a Wi-Fi password as a 123. In the LAN, this is the default IP address for the home gateway. In the internet, you will get an IP address from the DHCP, that is from the ISP router. So open your laptop, change the wired interface to wireless interface. So before changing, turn off your PC, change the wired interface to wireless interface, again turn on the PC. Click on the configuration, wireless, type the SSID, that is smart home, password is Azure123. In the configuration, you can see the IP address from the home gateway. configure the other IoT devices. Click on Advanced and change the voice interface to wireless interface. Get into configuration, wireless, type the SSID name, smart home, and the password. Request a DHCP IP address from the home gateway. So you can see the link is connected. Do this all for the other devices. In the advanced mode, IO configuration, change the interface to wireless, configuration, type the SSID name, password, request a DHCP IP address. So you can see the link is up. Do this for all other devices. Change the interface, configuration, change the SSID name, type the password, request a DHCP. So you can see the link is up. For the other devices, I will use a LAN wire, that is straight through cable, on the Ethernet one, fast Ethernet. Click on Advanced, configuration, fast Ethernet, request a DHCP. So the link is up now, showing green button, request a DHCP. Click on the config tab, fast Ethernet, request a DHCP. For this one, click on the config tab, fast Ethernet, request a DHCP. So this is the configuration on the home gateway and the other devices connected to the home gateway. By using a drawing palette window, we will differentiate the networks by name. Choose some color for the network. This is a home network. Select other color for the other networks. This is an ISP servers. This is a cellular side network. By using a place node, name the networks. Please home network. This is ISP servers. This is a street network. Give an IP address for this. Type the IP address for this network, that is 192.168.25.0. So next we'll configure the ISP router. Click on the ISP router. So this is how the real-time router looks like. You can add the interfaces in these empty slots. These are the WAN ports. Click on the command line interface. Say no to configuration dialog box. Enable the router. Get into the configuration terminal. First we'll configure for the ISP server interface, that is gigabyte 0/0 interface, gigabyte 0/0. Give an IP address, it is 10.0.0.1, and the subnet mask for that IP address 255.255.255.0. Say no shutdown for the link up. So the link is changed from down to up. Now configure the cellular side network, that is for the interface gigabyte 0/2, interface gigabyte 0/2. I'll give public IP address so it look like more real-time scenario. I'll take an IP address 209.165.201.250.225. The subnet mask for that IP address 255.255.255.224. Say no shutdown. The link is up, so you can see the link is changed from red to green. For the home gateway interface, that is gigabyte 0/1 interface gigabyte 0/1. Give an IP address, that is 201.209.165.200.network 200.225, and subnet mask for that IP address 255.255.255.224. Say no shutdown. The link will get up. So you can see the configuration is done on the ISP server. All the link state is up. Exit from the router. By using place node, name the IP address, that is this side of the network, that is 10.0.0.0th network. This side of the network is 209.165.200.0th network. On this side of the network is 209.165.201.0th network. So we'll configure the ISP as DHCP. Click on the router. Get in the configuration terminal. IP DHCP, excluding the IP address, that is 209.165.201.225 to 209.165.201.229, and the network pool IP DHCP pool, name of the pool cellular, and the network IP address 209.165.201.224, and subnet mask for this IP address 255.255.255.224. A default route for this side of the network, that is 201.225, and the DNS server 10.0.0.254. Exit out of this configuration and configure for the home gateway DHCP, that is IP. Change the network ID from 201 to 200, that is this side of the network. As you can see, that is this side of the network, 200, and give a network pool DHCP pool as WAN clients, and the network address change this 201 to 200.network, and the default route is this, and the default route is this link address, and the DNS server. Exit out of the configuration. So the configuration is done, the DHCP for this ISP is done. Check whether the IP address is enabled or not in the central office server. Go in the configuration, backbone, request a new DHCP. So you can see the default gateway and the IP address given from the ISP and the DNS server. This is the default gateway for the cellular side network. On the WAN, change this Ethernet cable. Click on the configuration, change the Ethernet 6 to cable, from DSL to cable, and in the cable add this port, from port and the to port, that is from the Ethernet port to the coaxial port, or the coaxial port to the Ethernet port. Check the home gateway whether the IP address is received from the ISP server, that is 209 is the default gateway and the IP address from the ISP and the DNS. So next we'll configure the DNS server. Click on the server. So in the real-time scenario, this is how servers look like. Click on the desktop, IP configuration, given static IP address, that is 10.0.0.254, and the subnet mask 255.255.255.0. Default gateway is 10.0.0.1, that is this side of the network, and the default DNS server is 10.0.0.254. Close the tab, go in the service, turn on the DNS service. For the configuration of IoT server, click on desktop, IP configuration, give a static IP address 0.253 and the subnet mask 255.255.255.0, and the default gateway is 10.0.0.1 and the DNS server is 10.0.0.254 and the DNS server is 10.0.0.254. Click on the service tab, turn on the registration server. By using a place node, name the servers, that is 10.0.0.254 and 10.0.0.253. After the configuration of IoT server, we'll sign up into the IoT registration server. Click on the laptop, select the IoE monitor application from the desktop, type the IP address of the IoE server, that is 10.0.0.253. Username is admin, password is admin. Sign up for the IoE account, type the username and password and create an account in the registration server. After creating, you can check the server has username and the password. So configure the IoT devices to the IoT server. Click on the IoT device, remote server 10.0.0.253 and the username is admin, password is admin. Click on connect. Remote server 10.0.0.253, username is admin, password is admin. Click on connect. So you can see you can refresh the connection by clicking on refresh. So for this device, you find this IoE settings in the settings tab. This remote server 10.0.0.253, that is IoE server's IP address, and the username is admin and the password is admin. Click on connect. So do this for all the devices. 10.0.0.253, username is admin, password is admin. Click on connect. .0.0.253 admin and admin. Click on the remote server and type the IP address 253, username is admin, password is admin. So all the devices are registered for the IoT server. You can check. Click on the laptop, IoE monitor application, Log in into the application, that is 10.0.0.253. Username is admin, password is admin. So you can see all the devices in the home gateway can be accessible through only one laptop. This ceiling fan you can turn on, off, so you can see the changes here. You can keep high, you can keep low, or you can turn off. For the door, you can open the door. So this is locking. If it is red, it is locked. If it is green, the door is unlocked. So for the light door, you can see the changes here. You can turn on the light, you can dim the light, you turn off. For the siren, on the siren, turn off the siren. You can open the window and close the window, open the window and close the window. Click on the camera and you can see the camera. So log out. Assign the IoT server's IP address in the DNS server. Click on the DNS. Add a name, that is www.iot.org, and give an IP address of the IoT server 253 and add it. If you access through the browser www.iot.org, it is possible. Click on go. So after the configurations, after the configuration of all the devices to the IoT server, you can give an IoT server's IP address into DNS. So after all the configuration of the devices, you can give this IoT IP address into DNS. Just click on DNS, add the www.iot.org, type the IP address of the IoT server 0.253, click on add and save. So after configuring the DNS server, the IP address of IoT server, click on the laptop, open your browser in the desktop, web address. You can access the registration server login. You can type in admin and sign in. You can see all the devices of the home gateway. You can access all these devices from the smart home, that is outside the network, from the street network. Click on the smartphone, desktop, and use IoE monitor application. Type the IP address of the IoE server 0.0.253. Username is admin, password is admin. Login. So you can see the devices listed from the home gateway. You can access through the cellular tower from the smartphone, that is in the street network outside this area of the home network. You can turn on the ceiling fan, keep it low or off, and you can use the webcam to see who is there at the home, and you can close the windows or open the windows. Log out. So in the Cisco Packet Tracer 7.0, you can do lot of changes, as I said. So you can change the conditions of IoT devices, such as when you open the door, the siren should turn on. That can be done by the programming language. So go in the programming tab and the main JavaScript. So you can see the program is here. You can edit the program or you can write the new program according to the requirement, and you can use. So this is how the working configuration of IoT devices and networking devices for the smart home with some gateways and servers. Thank you for watching. So this is how Cisco Packet Tracer works. Hope you understood how to download and install, interface overview and the new features, configuration of IoT and networking devices implemented on smart home virtually. Try to implement this in real-time scenario and make some time. Try to practice more and more examples. That's all about Cisco Packet Tracer. Thank you for watching. Signing out.